Hello everybody and welcome back to the Programming in the C Language tutorial series. Today we're going to be talking about some basic data types. I made this beautiful little slideshow just because it's going to illustrate the point more, and this is more on theory than code. So rather than showing you guys in code and all that kind of stuff, I'm going to be showing you guys a little slideshow just to make the video more interesting. So let's go to the first slide here. So we're going to be talking about an integer first, and an integer in both math and computers is any whole number. Now, in computers there are two different types of integers. There is an unsigned integer and a signed integer. The difference between the two is signed integers can store negative numbers, like numbers in the negative range as well as the positive range, hence why it says sign. It can contain a sign bit. And an unsigned number can only hold positive numbers. So a signed integer can hold values between negative 9.2 times 10 to the 18th to 9.2 times 10 to the 18th. So those are very, very, very large numbers. If you are programming something that's not going to be taking values that big and you are concerned on performance, you might want to use a short or something that takes less memory. But that takes that's 8 bytes. That is int64, that type. An unsigned integer can hold an even higher value. It can hold from 0 to 1.8 times 10 to the 19th, which is exactly double of the range of a signed integer because you don't have that negative range to worry about. But generally, you should use a signed integer over an unsigned integer, simply because it could lead to inconsistency, and the compiler will throw a warning if you try to compare a signed and unsigned value, and it could lead to unexpected results and bugs in your programs. So now we're going to talk about the space with an integer. So in 64-bit systems, an integer takes 8 bytes. In a 32-bit system, an integer is 4 bytes. So to represent a number like 64,128, don't ask where I got that number from, I just kind of pulled it out of my head. You would take this number and convert it to hexadecimal, which you would get FA80, and then in memory it would be stored as 80FA00000000000000. The reason that we have this kind of reverse order is because most systems run on Little Endian. We haven't talked about Little Endian and Big Endian yet. We will get into that, but that is the order. And then if we wanted to write to memory or something using a pointer, for some reason, we would have 0x80FA, and then all of those zeros at the end. You would have 6 bytes of zeros, right? Because 64,128 only takes 2 bytes out of the 8 bytes that is allocated. So a character, in all systems, a character is generally 1 byte, because most symbols, including null terminators and all of the alphabet and all that kind of stuff, and punctuation, is stored between 0 and 255. The maximum value for 1 byte is also 255, 0xFF. So to represent a number such as J, which is 74 on the ASCII table in base 10, the hexadecimal value for that is 4b, so that is what is stored in memory, because memory is done using hexadecimal. So float and double, these are our last data types. These are for representing decimal numbers. So something like pi, for example, 3.14159, and then all the other crazy numbers. By the way, we will never be able to store the complete number of pi because it's infinitely long. Anyways, I just thought I'd throw that in there for no reason. So a float is less precise than a double, and it consists of 4 bytes. A double is the same. It also represents a decimal number, but it is more precise because it can consist of 8 bytes. Now, these are situational. There are certain situations where you'd want to use a float, and there are certain situations where you want to use a double. There's a saying which is, only be as precise as you need to be. This is for both performance, because you're not taking up as much memory as you may need, and to prevent possible bugs at runtime. So that is it on data types. I hope you guys enjoyed the video. If you did, please leave a like below, comment any questions or comments you guys may have had on the video, and subscribe. I know it was kind of a short video, but we're just covering the fundamental data types. I don't want to go into stuff like pointers and all that kind of fun stuff yet, but we will get into that, of course, soon. But these were just the fundamental data types. So you've got an integer and characters and float and double. And most other data types, such as even a C string, is just an array of character bytes, right? So yeah, so I just thought I'd cover that today, and I hope you guys enjoy the tutorial, and comment any questions you guys have, and I will see you guys in the next video.